Okay, so today we're going to talk about polar coordinates, which is an alternative system to sort of designate points in the plane. So the normal way that we designate points in the plane are we have our x-axis and our y-axis, and we specify some point like this. We have some x-coordinate and a y-coordinate, and we label our point accordingly. All right. Well, we don't have to label the plane this way in terms of x and y. There's an alternative system called polar coordinates. And what polar coordinates do is they reference the positive x-axis here, an angle that you sweep out, and then a direction and length that you go. So here is a basic diagram of what one might look like. So let's say we have this same point here, and we would typically call this point xy. And these kind of coordinates are called rectangular coordinates because they form little rectangles. But let's say that we're going to work on polar coordinates instead. What we do is we draw a little spline from the origin, and then we measure an angle relative to the x-axis in standard position, so it sweeps out upward, and we call this angle theta. And then if we're pointing in this same direction that the spline points to begin with, we use the length r here, which is the length of this section here. And instead of designating this point as x and y, we can designate this point as r theta. So we could designate any point in the plane, and just to illustrate, let's pick some other point here. Let's say that we're over here. We can draw our spline like this, designate our angle, theta, and then have the distance right here as r. So this point could be represented as r theta. I should say that you may think that r and theta should always be positive, but that's not really true. Theta can be negative, but it doesn't really screw anything up. So if we had, say, a negative theta, we could do this. So let's say the point was here, and instead of wrapping all the way through, we just went down like this. This is technically okay. And we're still pointing in the same direction here, so this is r here still. Now things are going to get a little bit quirky when r starts to become negative, because as you can see, all these things sort of point in the direction that you land after you sweep out theta. But if for some magical reason r is negative, it will point in the opposite direction of what the regular r points. So if we have negative r, it'll point this way. And in this instance, in this original diagram, theta and negative r will point this way. And on this one, negative r will point this way. So this is the positive r and the negative r. You sweep out, in that direction you point is the positive r, and the negative r is the opposite direction. So let's just do a few examples here. All right, so the first example I want to do is 3 7 pi over 6. And we're going to do 2 here and 2 here. So if we do this, I generally try to find my angle first. So if I look, I would sweep out here from the positive x-axis to my angle, and then I would start from the origin and venture out 3 spots. 1, 2, 3. Like that. So you would sweep out this direction all the way to 7 pi over 6, and because this is positive, you would travel out in this exact same direction. All right, so that is this point right here. Let's call that A, just for reference. All right, let's plot another one with a negative radius. Okay, so 2 pi actually isn't marked here, but we know that 2 pi and 0 are the same way, so we would sweep all the way out back to here. Now you see that we would be pointing in this direction here, But because our r is negative, we go the other way. So instead of pointing 3 this way, we point 3 this way. 1, 2, 3. And this is point B. Okay, so we've covered positive r, positive theta, negative r, positive theta. Let's do one of each of the other kinds here. So let's have a positive r and a negative theta. Okay, so what we're going to need to do is sweep out this angle first. So you need to know that negative pi over 4 will just be pi over 4, but in the opposite direction. So instead of sweeping up like this, we'll sweep down like this. Okay, so we know we're going to be pointing in this direction, or possibly this direction, but because our r is positive, we point this way. So we know we're here at negative pi over 4. So we swept out this way, and then we move outwards from the origin 2 units. 1, 2. Okay, let's call that point C for reference. All right, we got one more here. So we had positive, positive, negative, positive, positive, negative. We'll go with a fourth point where we have both negative. Okay, so negative pi over 2, you go this way, right? Instead of going up pi over 2, you go down pi over 2. But because the r is negative, you don't point this direction, you point the opposite direction. So instead of going 6 out this way, we go 6 out this way. So we go 1, 2, 3, 4, 5, 6. Okay? And that's how we plot polar coordinates. You sweep out the angle, and then you accommodate for the r, whether it's positive or negative. If we need more examples, I can do those in a later video.